Assalamualaikum warahmatullahi wabarakatuh. My name is Aliya Husna Fayyaza, and today I will be presenting my project called the Block Blast Puzzle Solver using the A-star algorithm. Block Blast is a puzzle game played on an 8 by 8 grid. And for every turn, players will get 3 randomly shaped blocks and have to place them on the board. Once placed, players cannot move or rotate them, so every decision really matters. The goal is to fill a row or a column with blocks to clear them. The game ends when none of the 3 blocks can fit on the board anymore, regardless of the order. In this project, I used the A-star search algorithm to find a valid way to place all the blocks. A-star works by choosing moves that balance two things. The first one is how far you've already gone, or represented by the G function, and how promising the current state looks, or represented by the H function. So the total function, or as called by F function, is G plus H. In my program, I calculated how much usable space in terms of blocks is left on the board, specifically how many empty areas are large enough to fit the remaining blocks. This value then is negated so that the birds with more usable space will have lower F function scores and be prioritized by the A-star algorithm. The input comes from two files. The first one is map.txt for the puzzle condition and blocks.txt for the block shapes. For example, I have this input blocks.txt, ABC representing the blocks and the map condition. The heuristic function is implemented in the function reachable empty cells, which uses the DFS to find open spaces that are still bigger than the smallest blocks that are to be placed. Now to the core function, the A-star solver. The first one is the initialization of the birds. There's the heap, the visited set, and the iterations all initialized to 0. And then through the search loop, while the priority queue is not empty, the state will with the lowest F function is popped from the heap. And then if all blocks are placed or the all current place is true, the current board configuration is returned as the solution. And then to the state tracking algorithm, to avoid redundant computations, each state is uniquely identified by its board layout and placement status. If a state has been visited before, it is skipped. And then for the expansion part, for each unplaced block, the algorithm tries every possible X, Y combination on the board. If the block can be placed or the can place returns true, a new board is generated by place block and new state is created. This new state has G plus 1 as its path cost and recalculates the heuristic age. It is then pushed into the priority queue for exploration. And then if the heap is exhausted but still no complete configuration has been found, the function will return none, indicating that there's no valid placement for the blocks or there's no solutions. There's also some helper functions like the clear full lines, which implements the line clearing logic when a row or a column is fully filled with blocks. This function is called in the place block here and does a checking for every new blocks placed. There's also a can place function and the can place function to check if block can be placed at a position, and the print board to print board with colors. Now I will demonstrate how the program works. So I already have this input blocks.txt and map.txt as I mentioned before. And then I have to run the blockblast.py. And then the solutions will be in the output. As we can see, the original map is kind of full of blocks, but since there's blocks that can clear the row or the column, all of 3 blocks can be placed. That is all for me. Wassalamualaikum warahmatullahi wabarakatuh.